Ships, trains, trailers, and barbecue pits. What do these things have in common? They all contain welds to hold them together and use in daily life. Almost all metallic objects are welded together for structural support and has been used for over 100 years. As someone who's been welding and learning about it for a couple of years now, there's a lot to learn from different types of welding, their applications, and the conditions which decide what method to use. Today I will be discussing the different types of welding, their applications, and the special types of welding rarely used. Each stick welding electrode is unique. Some are good for rusty material, some only for clean steel, some for uphill, some for downhill. Every electrode type also comes in different diameters. Some of the standard electrode diameters are 3/32, 1/8, and 5/32. Understanding how base material thickness relates to electrode diameter selection is very important in order to achieve a professional quality weld. Identifying an S-small electrode is a fairly simple process. At the base of the electrode where the flux stops is a 4 or 5-digit numerical code that will tell you a few things about the rod. It will often look something like this. Let's review the identification system with the E7018 electrode. The first letter you see is the E, which stands for electrode. An electrode is simply the consumable conductive part of the welding circuit that creates the welding arc via an air gap to the base material. The first two numbers in the identification are often coupled together, usually resulting in a 70 or 60. This is an indicator of the tensile strength of the filler material in the electrode. This is most often referred in thousands of pounds per square inch. The 70 identifier would be a 70,000 pound tensile strength filler material. To properly understand how this relates to your workpiece, we need to look at what tensile strength means. Tensile strength is a measurement of the force required to pull something such as a rope, wire, or structural beam to the point where it breaks. The tensile strength of a material is the maximum amount of tensile stress that it can take before failure, for example, tearing or breaking. Moving forward, we will be looking at the third digit in the welding code. In our example above, the number is E7018, so our third digit would be a 1. This number is an indicator of the applicable welding position. Number 1 indicates all position. A number 2 would indicate a flat and horizontal only. And number 3 and 4 would identify electrode as being able to weld only flat, horizontal, vertical down, and overhead. The fourth numerical digit is the electrode identification number, indicates flux composition. Each electrode is designed for a different application. The E7018 is a low hydrogen iron powder type electrode that produces high quality X-ray welds. It can be used in all positions on AC or DC reverse polarity welding current. It is recommended for welding medium grade carbon steels, normally exhibiting excessive porosity when welded with conventional electrodes. Typical applications are low alloy structures, low, medium, high carbon steels, offshore rigs and power plants. Steel structures, tack welds from tubular wire applications, and then we move on to E6010. E6010 is a mild steel, all-position electrode designed primarily for use on AC power sources. It provides a strong arc force for deep penetration and a fine spray transfer that enhances operator appeal. The fast freezing or rapid solidification of the metal allows welding in the vertical and overhead position. Its light slag eliminates slag holes that are prevalent on some applications with other electrodes. This product can be suited in a wide range of applications. The typical applications include general purpose fabrication, galvanized steelwork, structural work, shipbuilding. Now that we know about stick welding, let's discuss MIG welding. Hardwire is the most common wire on the market. Most fabrication shops will have a majority of their MIG machines set up to use it. It is relatively affordable, and beginners will have an easier time with learning hardwire than they will with other wire types. There are so many bead patterns and techniques that you can use to achieve some amount of penetration with hardwire. Different welders or fabricators will have beads that look dissimilar to one another. Some people will push their puddle, while others prefer to pull. There are multiple types of hardwire. They are all meant for welding mild steel, but vary in terms of how hard they actually are. Some wire has properties that will make it harder than the steel itself, while others are a bit softer. Due to the fact that there is no slag involved, hardwire is one of the fastest processes for fabricators who want to increase efficiency. You can weld in literally any position with this wire type: uphill, downhill, flat, horizontal, overhead, diagonal, etc. Another type of welding wire is flux core. It's a bit different. Flux core uses a flux-filled wire as well as shielding gas. About a 75-25% of argon and CO2 mix is often used during this process. This dual shielding process achieves ultimate penetration with two shielding properties and is a choice of many structural welders worldwide. The beads are much wider than most of the stick welds, and the characteristics of the dual shield flux core can penetrate through rust in heavy mill scale. For structural fabrication, shop workers need to be able to make quick work of I-beam projects, and stick welding can be a real hassle with that kind of thing. To avoid rod stubs all over the floor and constant replacement of rods, using dual shielding instead can skyrocket the productivity of beam fabrication. If you are fabricating on a strict time frame and must maximize the working hours in a day, dual shield is really worth looking into. Now let's discuss transfer spray methods, or how the wire transfers to the base metal. Short circuit transfer is a transfer when a low voltage is used for MIG welding. Short circuit transfers occurs when the wire contacts the metal, creating short circuits. During this short circuit, the wire contacting metal heats up and melts into the joint, creating a puddle from the contact. Then another contact begins, and the process keeps repeating many times a second. The sound greatly resembles an egg hitting an extremely hot frying pan or a high-pitched crackle. Globular transfer occurs when the wire arcs and it creates a glob that hangs off the wire. Then the glob falls to the metal, filling the joint, and the process begins again. Globular transfer has a slow popping sound to it. Spray transfer is a transfer where a higher voltage is applied and the electrodes do not contact the metal. The wire sprays or has very fine mist transferring to the metal. You can also see a clean arc to the metal and will not have any spatter. Spray transfer can also be defined by a minimum amperage setting by welding engineers for thicker metals. We've discussed the main types and their applications. Now let's discuss a few specialty welding procedures. TIG welding is a manual welding process that requires the welder to use two hands to weld. One hand is used for holding the TIG torch that produces the arc, and the other one is to hold the filler metal to be added to the weld joint. This process is slow, but when done right, it produces the highest quality weld. TIG welding is mostly used for critical welding joints, welding metal other than common steel, and where precise small welds are needed. Hyperbaric welding, or underwater welding, is a process of welding at elevated pressures, normally underwater. But it can be done dry outside of water in a pressure chamber. The applications of hyperbaric welding processes are diverse. In its wet form, it is used often to repair ships, offshore oil platforms, offshore pipelines, and steel is the most common material welded. When using robots for any process, the method requires amending to accommodate automation. The robot itself has an arm that can move in 3 dimensions through more plans with articulated versions. A wire feeder sends the filler wire to the robot as it needs to be for a welding job. A high heat torch at the end of the arm melts metal to enable the welding process. Because the temperature reaches thousands of degrees, using robots for this process keeps people safer. Although a certified human operator still needs to remain close to the robot. Today I've discussed several different welding procedures, their applications, as well as some specialty welding procedures. So next time you're sitting in a car or in a chair towing a trailer, remember that someone took the time to weld these pieces together so you can use it.